Okay, so I propose that we start. Thank you for all coming here today. The presentation will be in English, but if you have any question in French, just feel free to ask. Can you just tell me that you hear me well, or should I speak louder? Thank you. So before starting the presentation, I would like to give a few words for the context. So I'm a PhD student, in my second year working at the Hélène department. And I am a member of the IEEE student branch. So you can see the IEEE, our logo on the right. And so what is the IEEE student branch? So it's an organization made by PhD students, which organizes throughout the years, so social events, industry visits. We also do contacts between master students and PhD students, and a lot more. So if you are interested in any of our events, feel free to reach us. We have Adrien right there, which is our chair. So, and if you would like to join us, feel free also to ask us any question. So this presentation was also prepared by Olivier Leblanc, which is sitting right there. So that's not only my work, but the work of both of that. So I propose that we start. And in order to introduce our topic of today, so the Manim. So what is Manim? I'd like to show you a small 36 seconds video, and then we'll continue commenting on this video. If I can see my mouse right. On the wrong screen. Okay, so the video that you've seen was generated as written with Manim. So the Manim is the topic of today, so what we will talk about. And I think that this video shows a little bit what we can do with Manim. I'll show more in the next of the tutorial. But I think that maybe many of you are similar to the kind of animation that we are looking at, and maybe some are not. But the goal of today is to understand how we can generate such kind of animations, and that you will be able to use either for your own content or to use it for educational purposes, like to teach your students or whatever you want. So, oops. So the contents of today will be as follows. So the first section will be dedicated to understand what is Manim. So what do we refer to when we talk about Manim? Then the second part of the presentation will be dedicated to discuss and compare the two versions of Manim. So we have two versions of Manim. We will see why, and we will understand what are the differences between them. Then we will see in the third part actually how you can use Manim and when it's useful to use Manim when compared to other tools. And in the last part, we will discuss and present additional tools that you can use to enhance your experience with Manim. So some forewords, I'd like to mention that everything that you will see today, so this presentation is recorded, but all the slides, the code, the documentation are all available in open source. So if you'd like to generate anything that you've seen during the tutorial, you will be able to do so just by looking at the codes, and it's quite well documented. And on the last slide, you will have QR codes that you will be able to flash. So you don't have to use your computer for the moment, at least if you are not online. So first things first, what is Manim? Well, we think that in order to understand what is Manim, you first must know who is this guy. And if its face is not familiar to you, maybe is this logo is. And if not, well, I won't go longer on this. It's a YouTuber, 3Blue1Born, which is also called Grant Sanderson in real life. And he's the guy that made Manim. So everything that you will see today, or most of what you will see today, is made thanks to this guy. So he's a very popular YouTuber that makes videos about mathematics, and most of them are animated using Manim. So what is Manim? So the question of this part. Well, to quote 3Blue1Born, Manim is an engine for precise programmatic animations designed for creating explanatory videos. So we think that's a bit of a verbose way to present Manim, and we would like to use a more concise way, but also broader. Our definition is that Manim is a Python tool that facilitates creating math-related videos. And we would like to insist on the related part because it's not always going to be about mathematics. You can do, and you can actually use Manim to do other things that math-related video or just math-only videos. So did I just say Python? Yes, and I think that some people would argue that they don't like Python or anything else. And we would like to catch some answers, some questions and answers that you might have when you hear about a Python tool. Well, first is that you don't know anything about Python. Well, I think that you're lucky because it's one of the easiest programming languages to learn. So if you don't know anything, that's not going to be a problem to use Manim, at least not in the first place. Then you have many examples to learn from. So most of the time when you learn a programming language, you will go through the building blocks of this language, and you will try to learn how to build things blocks by blocks. Here, you would most likely just look at an animation, then watch the code of its animation, sorry, and then you will try to understand what is the logic behind the animation. You can also not like programming. When I think that creating animations, as you will see in the next slide, requires very basic programming knowledge. So you will never feel like you're programming when you're doing Manim animations. It's like when you're writing LaTeX, you don't feel like you're programming, but it can be similar. You can do have a similar approach to Manim. Here, you will have things that are so high level that you will not have to go deep down in the programming aspects. And a third point that we can mention is that people usually run into troubles when installing Python models. Well, here we are very lucky because it's a quite well-documented tool. So it will work on Windows, on macOS, and Linux. And the installation process, as you will see, is very easy. So don't be afraid to try it on your own computer. So the philosophy when creating Manim animations is can be split into 3 parts that we called ABC. The first part is that you will create a scene file. So a scene file is just a description of everything that you would like to show in your video. So here, for example, I'm going to show an animation which is going to transform a square into a circle. So the circle is going to be red. Then I have the square. I create the square. I transform it. And then I fade out the square which was transformed. Then the second part is going to be about creating the video. So you had a Python file. Then you want to have a video file. You just have to convert it using the tool. And then, of course, you have to watch the video. And if everything worked correctly, you should have something like that. So you create, you transform, then you fade. And you can see that in a very few lines, you have generated something that is quite neat to look at. So what are the motivations to use Manim? Well, I think that we think that the most important ones are that in a very few lines of code, you can create nice and precise animations. And in most ways, it will facilitate the scientific communication. So we often say that a picture is worth 1,000 words. Well, what about a video, which is just about a bunch of pictures? And the other motivation is that it's not only limited, as I said, to pure mathematics. And to further motivate the need, I will say the benefits from using Manim, I would like to go through a small example. So here, I'm sure you all know the Newton-Raphson scheme, but let's imagine that you're in a class and you have to teach the students how the Newton-Raphson iterative scheme works. So how does it work? Well, that's a scheme that is used to find the root of some function f, and you have on the left part the new value of your root that you're trying to look for, and then you have the old value, and each value will be incremented by some delta, which is a function of the function itself and its derivative. So here you just have the scheme, and you're trying to show the iteration to your students and to have a glimpse of what will be the impact of the function, what will be the impact of the tangent of the function, and that can be quite hard if you have a lot of points to show. So, for example, you could just plot a graph with a bunch of points, a bunch of iteration points, but it will take a lot of space, or you just have to generate a graph for each iteration. Well, with a video, you can do all that in just one video, which is, sorry, I'm always losing my mouse. So here I'm showing the tangent, then the increment, and each step I will show how far we will go. And we can see that the impact of the tangent can be seen just throughout the blue line, which is the tangent, the local tangent to the point. And with this example, you are able to also see the transition between each point, which in some cases can be a good advantage when you have something that is hard to see just on the paper or just on a few graphs. So now for the second part, I would like to just discuss between the two versions of Manim that you will encounter most probably. So if you type on Google Manim, then you will find something similar to this. I'm not saying that you will have the same two first results, but the first result is the Manim from UCLouvain, as you can see, and the second one is the Manim from the Manim community. And when you face that kind of result, you might wonder, well, which version should I use? Which version is the right one? And why actually are there two versions? Well, to understand why there are two versions of Manim, I think it's good to go back in history. So in March 2015, UCLouvain, so the YouTuber that we mentioned earlier, made his first video. And if we look at this video, we can see that he was actually already using some kind of Manim. Then back in 2018, he announced in a video FAQ that he was actually using a tool. So prior to that, nobody knew that he was actually using his own tool that he developed. But at that time, he was not planning to make it public. But later in 2019, he made his work public. And in 2020, a fork of his work was made from the Manim community. So just for people who are not familiar, a fork is just like you clone the work of someone, but you keep some links between the original work and your work, so that if the work from UCLouvain is updated, you can easily update the fork, and back and forth, of course. So if you go to the first version, the version from UCLouvain, and you go to the website, you will find something like this. And the goal of this version, actually there is one main goal, is to match UCLouvain's needs at a given time. meaning that if he wants to do a video about cats, then he will make sure that his engine is able to generate such videos. And that's the main thing that you have to have in mind when using this tool. So this tool is not made for other people than 3Brew1 Brown. On the other end, we have the Manim Community Edition, which has a different website, and its goals are a bit different. First, it strives to be easier to use. Then it tries to be also more stable over time. It is well documented, and it's community driven, and we will why it's good later. It's also important to compare how we name both versions. So the first version is called Manim GL. GL is because they use OpenGL to render the videos. And the Manim Community Edition is often referred to as Manim, just short for Manim, or Manim CE for Community Edition, of course. Then we have the command name that you just have the Manim GL in lowercase and Manim for the second one. But the tricky part is that the Python module for the first one is manim lib, whereas the second one is manim. So if you just want to keep things simple, you should use the second one because it's just easier to not confuse and to make sure that you use the right tool. But that's not the only reasons that you would prefer the community edition rather than the 3Brew1 Brown edition. So when I will later refer to Manim, I will talk about the Manim community edition. And when I specifically refer to Manim GL, I'm talking about the version from 3Brew1 Brown. So what are the reasons that we see to prefer Manim? Well, the first, so Manim community, as I said. First, it's easier cross-platform to install. Second, it does not require installing OpenGL, and I think that most of you maybe don't care about that, but that's something that can be hard to install depending on the platform. It's also maintained by the community, and it has two advantages. Well, the first one is that if you make a change, a lot of people are going to review it, meaning that if it's a breaking change, like it will break things in the future, it's most likely going to be caught by the people because more people are going to watch at it. And it's also more stable across time, meaning that if you created a video 2 years ago, so you just made a Python file, then it's most likely that you will be able to generate the same video with the new Manim version of today, which is not the case actually with the version of 3Brew1 Brown. And it has a very, very good documentation. And you see throughout the slides links in blue. Once you will get access to the slides, you will, of course, access to those links. And what are actually the reasons to prefer Manim GL? Well, the first one is that 3Brew1 Brown made all its work public. So if you want to generate the video that you've seen on its channel, then you can easily download the code and use his version to regenerate the videos that he made. And we actually have a tutorial. So at the end, when you will have access to the GitHub repository, you will be able to generate videos from 3Brew1 Brown. We explain how to do that. But that won't be the case during the tutorial. And the second reason might be that you need features that are currently only available with Manim GL. So for example, he made something that's for the purpose of some videos that's not already on Manim, and you want to use it, then you should use Manim GL. But we think that if you don't care about any of those reasons, prefer to use Manim Community Edition because it's going to be a much nicer experience and with less bugs and so on. So the biggest part of this presentation, and I think the most important one, is how to use Manim. So how do you use it and when to use it? Because it's not always smart to use Manim in every single case. So What do we assume that you have? Well, as documented on the GitHub, we assume that you have Python, because without Python, you cannot run the files. And you have basic knowledge in Python, of course. In Git, that's not mandatory, but that's still a good thing. If you want to have LaTeX equation in your slides, of course, you need to know a bit about LaTeX and command line, but that's a very basic knowledge. And if you have troubles in one of those topics, so if you don't know anything or you'd like to know more, on the GitHub README of the repo, we link to some very good documentations. So how do you install Manim? Well, it depends on your platform, but it's very, very short, regardless of the platform. So here are all the links towards the documentations, but here that's just, and you actually don't need to type the comments because you will do that later. But to install on Linux, you just install the dependencies in your one line. You install Python if you did not already have that installed, and then you just install Manim. So the installation process on Windows is just one line instead of all those lines, and on Mac, I think that's very similar to Linux. Then, once you have Manim installed, you can start creating scenes. So I will go a bit more into details than the previous scene. So you have to create a file, of course, a Python file, which is here called myfile. And then you have to import everything from Manim. People might argue that that's not very common to import everything from a Python module. But here, that's going to be much easier because we have a lot of functions that we can use, of classes. And then the easiest thing to do is just to import everything, and that will probably never do anything wrong with other packages that you are using. Once it's done, you create a scene, and a scene is just going to be a sequence of animations. If you want to have multiple scenes, so because you want to separate just your work, you can do also. And the important part of the scene is the construct method that you have to create, which is going to contain every single animation and, of course, everything that you need to create those animations. Here, I'm just going to create a square. So I create a square from the square class. Then I will play animations with the self.play method. So the first one is going to create the square. Then we will animate a rotation, then we will change the color, then we will do other fancy stuff. And you can add or remove any of those if you want to try different combinations. The next part is, as I said previously, is to render the scene. And the rendering is very easy to perform. You actually call in the command line the tool. So Manim is the name of the tool. Then you have optional flags, which are not mandatory, as optional suggests. Then you have the name of the file containing the scene. And if the file contains more than one scene, you have to say which scene or scenes you want to render. So here I have my file, which is called myfile.py. I have my scene, which is called myScene. And if I did everything correctly, I should have that. So you have the square, you rotate, you change the color, then you circumscribe, and then you uncreate. And as you can see, as in the previous example, you can create very easily precise animations that look very appealing. So Manim is not only to create videos. You can create images, so as the logo on the first slide, but also the image here. So for example, you'd like to capture an important moment in your video, then you're able to generate just the image that you want. You can also generate a GIF. So you might know that you can use GIFs in some papers and not videos. So you might be interested in rendering GIFs. You can also render 3D videos. So it was not shown in the first showcase, but you can very easily That's just a few lines. I think that's under 20 lines of code to generate that kind of animation. One other thing that is very nice to do is that you can actually animate your own SVG files. So if you know UCLouvain Brown, you know that he has his very popular pi symbol that he makes moved and so on. So here we just have a small example. We have 3 files that were made by Olivier. And here you have a duck, then a duck with a slight move of the nose and the eye, and then we have a change of color. And we can use those files to create an animation. So you create the duck, then you change from one duck to the other. Then you can apply rotation if you want. You can do some wiggle and so on. So there is no limit to what you can create, but this file, so this video is also just under 10 lines of code. So that's really something that we would like to emphasize, is that things that appear hard to make are very easy. So then what's next? Because here we've not shown everything that you can do, and I'm sure there is a lot more that you can do. And we'd like to give you some other links. So if you are interested in using Manim, we'd like to mention the Made with Manim collection. So here you have a link. You will be able to go through it. So that's a collection of content creators that are using Manim in their videos. We also have, among those collections, Reducible, which is a YouTuber, which is also popular and that utilizes Manim for its videos. Maybe you might know the Summer of Math Exposition YouTube hashtag. So that's a hashtag under which a lot of videos have been made using Manim, a few hundreds. And if you have any question or if you're looking for inspiration, we'd like to mention that there is a Reddit. So Reddit is just a forum, and you have a Discord, but I'm sure you all know what Discord is. So the question is now when to use Manim. Well, the first question, sub-question that we would like to answer is that, is Manim for everyone? Well, yes, we believe that most students, professors, PhD students, master students, whatever, can benefit from using Manim. So either in your research or either in your classes or whatever you want, but there is always, I think, a case where Manim is worth using it. But is Manim for every presentation? Well, no, because Manim is best suited, of course, when animations make things clearer to the audience. So if you just have to show something that is a still image, well, it's not worth using Manim doing complicated stuff. What should you be aware of when using Manim? Well, as for everything, when you're trying to do a content that is more elaborated, well, it will take a lot of time. And it has 2 caveats. First, you will take time designing the animation, but also rendering. Because here, the small animation only takes a few seconds to generate, but it can take some minutes at the end to generate a longer animation. So if you want to create content with Manim, always think about the ratio between the time that you want to spend preparing the animation and actually the time that you will be presenting the content. And when is Manim particularly useful? Well, we think that it's small conferences talk, like a 10-minute talk, it will be very fine in educational posts or videos, blog posts, and so on. So in content that aims to be very short, but also precise and on a very specific ID. You can also start your own YouTube video channel and do a 40 or more minutes video. But here, that's just, we think the main use of Manim is to use it for very short videos. So now we'll just end the presentation with presenting some additional tools. So first, we'd like to mention the Manim plugins. So a lot of plugins have been created by users, and some of which can be found on the Manim community website, which has a page dedicated to plugins. And among them are plugins for Manim physics. So if you just like to simulate a body falling and bouncing on the ground, or a racked body, or stuff like that, you can use it. If you are into chemistry, then you can use Chanim, which aims to generate chemistry molecules and so on. Then you have machine learning concepts that can be generated with Manim ML. If you're into finite state machines, then you have automata and gearbox for gearboxes. And there are a lot more that I just did not mention. You can also use Manim inside Jupyter. So if you don't know what Jupyter is, it's just a way to present code and Markdown, which is just a markup text language. And you can embed so Manim inside Jupyter. And actually, all the slides that you've seen today were generated in a single one Jupyter notebook. So that's just to show that you can generate all the animation just inside the Jupyter notebook. You can generate after slides from this Jupyter. So Jupyter is a very convenient way to display and present the animation and content. And the only thing that you have to do is just to include this line on top of your cells that you want to generate the animation for. Just a side note, it's only available for the community edition, so not for ManimGL. That's the only tool that we presented today that is only for Manim community. And if you are interested in using it in a Jupyter notebook, well, the Manim community just wrote a comprehensive tutorial on how to use Manim, and they made it inside a Jupyter notebook. So you can just go through this tutorial and learn how to use it inside. There is a second tool that we would like to present, and it's Manim Slides. So if you remember the example from earlier, well, the problem was that it was a video, and you could pause the video just manually, but it's not always very neat. So what if we just could pause the video just like we would do with a PowerPoint, or go with backward, forward, reverse, and so on? Well, that's actually possible with Manim Slide. So that's a tool that you use on top of Manim or ManimGL, and you can turn any presentation into a PowerPoint-like presentation, meaning that between each slide, you will have natural pauses, and you will be able to control how you go through your slides. And how do you actually use Manim Slides? Well, it's very easy. So here we have the example from earlier on. So we imported Manim, then we created the scene, and we did a lot of some stuff. But the most important thing is that you plot the graph and you do the iteration. And now what you need to do if you want to use Manim Slides, well, you import it, you just change the base class, and then you add a bunch of poses where you want to have poses in your slides. And we would like to show you a small demo, how it works. So once you have generated the video with Manim, you can use Manim Slides. Yes. You can use Manim Slide, and here you see you have a pose. Then you can draw. Maybe I should not. Well, I don't know why it's low, but it should not be slow. It's because I'm on full screen, I think. Sorry for inconvenience. Yes. Yeah, I think my computer does not like to be recording on Teams and sharing my screen at the same time, but it should not be that slow, sorry. So the purpose of Manim slides is to be able to go through the animations. So for example, I just press next, and then I can go through each of the frames, or I can go back. If you want to restart, you can rewind an animation. If you want to replay it, you can play it in reverse if you want. But I really don't know why it's that slow, but it should not be the case. So if you're interested, there are links on the GitHub. But, okay. So that was all for the presentation. Would like to thank you for listening to us. As I said, the recording will be available on the GitHub, so we will make a link. You can flash the QR code if you want, or you can type in the links. If you have any questions, feel free to ask in French or in English. And I think that's everything I had to say, so thank you. Yes, Laurent. Yes. I think I can just click on the... So you have the GitHub page that you should be able to access. I will put the link back just after. So if you go to the slides, then you have a Jupyter notebook. And so because Jupyter notebook is just a sequence of code or Markdown, and Markdown can be actually everything because it's HTML, so you can put everything you want to. You just have here the code cells that we just ignore from the output. I don't know, there should be a coloring for Python, but that's not the case in the rendering from GitHub. So here, for example, that was all the animations that you had seen at the beginning. Then you have the table of content, then you put some images. So it's very easy to understand what will be the results. And I think it's maybe easier if I show the original file. Well, Jupyter is able to convert a Jupyter notebook to reveal slides. So if I really don't know why it's that slow. So if you go to slides, then you go to this file, which is very slow to load. Maybe I should. So here you have the Python cell. So a bit. So as I said, I was going to skip this from the outputs. And then, for example, the slide about the table of content is just you write Markdown, then you specify that's a slide, and that's everything you have to do. So if you want to generate the slide, we wrote the comment that you can type, so you can use it. That's a one-liner, and you generate from this file the slide that you've seen. And that's actually how we generate, because we take the file and we use GitHub Pages to upload the file and to generate everything you need, and that's uploaded then on my website. Any other question? The one at the back, then you, Antoine? you can use ticks in your in those animations. I'm not sure I have the example here, but I did so for a conference last year. I did all my slides using a Manim slide, and everything was done with LaTeX, and some slides were actually using ticks. So you can use ticks if you want in your presentation. Or you can use SVG, but the ticks is going to be translated into an SVG, which then will be used into your slides. Yes? Other question? Okay. I don't know if there are. Yes? What do you mean by that? So, yes. Well, I don't know if you know about GitHub Actions. So that's that thing that is things that are running on a server with no screen. And if you want to know how this the website is generated, well, that's everything you do. You need to know. So that's just a Linux server, but you install the dependencies. You install the LaTeX dependencies because I'm using LaTeX. Then you install the Python requirements. Then you generate the slides, and then I push everything online. And that's what you see at the end on the website. So yes, you can generate that on a separate server, and that's not a problem. I don't know. Are there questions on the team?